Hey there. So we are back talking about one of my favorite topics, which is a probability. And I'm in your workbook and I'm looking at page 27, about halfway down the page. Okay. And you should have read this over last week and hopefully it made some sense, but I do want to talk through it just in case you're left a little bit confused. So we've been talking about Venn diagrams. And the and is where the two circles overlap, right? Remember, we were talking about the yellow sheep, right? All the animals that were yellow were in one circle, all the sheep were in the other circle, and the yellow sheep were in the middle where the two circles overlapped. Okay, that is the and area, right? Or, if Mrs. Payne was making an announcement and she wanted everybody who took music and art to come down, you have to take both of them, right? That's that middle section. Well, what happens if there is no overlap? What happens if there are no yellow sheep or no students are taking art and music? We call those mutually exclusive. They can't happen at the same time. Okay, so the example here is that if we're spinning a spinner one time, right? Remember the multicolored spinner. We can't land on blue and red at the same time. It just doesn't work. Okay, so in a Venn diagram, two mutually exclusive events, they don't overlap. Right, so see how these circles, they don't even overlap. Or if they do overlap, there's just nothing in that center section. Okay, that center section is just blank or a zero. Okay, the probability of A and B happening, the probability of having a yellow sheep, or the probability of a student being in music and art would be zero if they're mutually exclusive. That's all we mean by mutual exclusivity. Okay. There were some practice questions you did. Hopefully those were making some sense. And what I want to do today is talk about ands and ors. And remember when we were looking at the Venn diagram, we were doing a lot of discussion about the difference between and or. Okay, and maybe I'll just draw a quick picture just so that we are all talking about the same thing. Right, so if this is our area, let's get no fill in there and a darker outline. There we go. And now let's draw some circles just to make sure we're all talking about the same thing. Let's make that, let's not have any fill. It'll be easier to see. Let's make it a red circle. And then let's make one more circle. And maybe let's make this a bright purple circle, also with no fill. There we go. Okay, perfect. So we have our two circles, right? And remember, if we had and, right, the and section is the bit in here, right? That's our and section. The or is everything in both circles, right? If we were told or, it would be everything here, kind of or anything there. We put them all together. Okay, so this is or, this middle section is and. Now, we can figure out probability two different ways, and it kind of depends on what information we're given. Okay, so if we're given the probability of A and the probability of B, we can find the probability of A and B. We can find the probability of being in this middle section by taking the probability of A and multiplying it by the probability of B. And all that seems fairly straightforward. So let's kind of check. Let's take a look at this example. So we randomly draw a card from a deck of playing cards. Okay, there are 52 playing cards in a deck. Okay, what's the probability that you draw a red card and a queen? Okay, well, for this example, we could probably do it two ways, and we'll do it kind of the logical way, kind of just using logic. Second, just to make sure that our calculations are right. So half of the cards are red cards, right? They're half red, half black. So the probability of A is 1/2. Okay. The probability of B, well, how many queens are there? There are 4 queens, 52 total playing cards. So the probability of A and B is 1/2 times 4/52. And if you wanted to change these into decimals, you definitely could. And we would see that the probability of A and B is 1/26. Okay. Now, I said there were 2 ways to think about this, and it's just kind of due to the nature of the question. We can double check to see if this is making sense, right? Let's think about a deck of playing cards, right? There are red cards, there are black cards, 2, 3, 4, right, all the way through ace. And we know that there are 4 queens. And we know that 2 of the queens are red and 2 of the queens are black. So what is the probability of a red queen? Probability of, let's just say, red queen. Because we know this information about playing cards, we know that the probability is 2. There are 2 red queens over 52, which is the same as 1/26. So this checks out. A lot of times we won't be able to do it this way because we don't know all of the details and we'll have to multiply our probabilities. But this is just to show you that kind of it does actually check out. Okay, so this is for and. A and B, probability of one times the probability of the other. Now, this works really nicely when we're talking about theoretical probability. But if we're talking about something that actually happened, right? Like flipping coins, we aren't going to get half and half all the time, right? So when we're dealing with actual data, then we're going to have to take a look at a Venn diagram, okay? Because doing this multiplication doesn't work. So let me show you what that looks like down here. We're back to this question. I asked 30 students, do you travel more than 30 minutes to get to school? And do you have a job? And so the results are given down here. The question is, what's the probability that a student travels more than 30 minutes to get to school and has a job? So we can't just take the probability of A times the probability of B and put it together, because we aren't really talking about theoretical probability anymore. We're talking about students' actual answers. So anytime we're given a Venn diagram, remember that the ands are down in here. It's where they overlap. So the probability of school, kind of more than 30 minutes, so let's say school and job, is 7 divided by our total, which is 8 plus 7 plus 6 plus 9, which is 30. Okay, so we can either look at a Venn diagram if we have one available, or we can multiply the probabilities if we can't make a Venn diagram. And it's the difference between theoretical and experimental. This is experimental. We actually asked a question. The above was theoretical. So that's if we have ands. If we have or statements, okay, there's that same division. If we have a Venn diagram, we can just look at a Venn diagram. Perfect. If we don't have a Venn diagram, though, we have to do our or statements a little bit differently. And this is going to be the probability of A plus the probability of B minus the probability of A and B. Well, why is that? What's going on here? Let's take a look at this picture up here. Okay, if we take the probability of A, right, or the probability of travel, right, in this case, that would be all of this, right? That would be everything that I've highlighted in yellow. That'd be the probability of A. And to that, we would add the probability of B. So what happens if we add the probability of B? Well, we've added the 7 a second time, right? The yellows, and it's hard to see, the highlights just kind of go over each other. But we had 8 plus 7, that was the probability of A, plus 7 plus 6, which means we've doubled this middle section, which is why we have to subtract it at the end. So let's look at an actual example. And you'll see that this example, I changed it a little bit from the example that was in your book. So, you might just want to make a note of the changes that happened. You're rolling a 6-sided die twice, so 2 times. Okay, and that's one of the changes. Instead of just rolling it once, we're rolling it twice. What's the probability of rolling a number larger than 3 on the first roll or an even number on the second roll? Okay, so just a slight change here. So if event A is rolling a number larger than 3 and event B is rolling an even number, then we can figure out the probability of rolling a number larger than 3 on the first roll or an even number on the second one. So let's think about this. We have the probability of A. Well, what is the probability of A? Rolling a number larger than 3 on our first roll. There are 3 ways we could do that. We could roll a 4, a 5, or a 6. So there are 3 ways we could do that out of a possible 6. Rolling an even number on our second roll. Let's find the probability of B. Well, that we could roll a 2, a 4, or a 6. So it also works out to be 3 over 6. And the last thing we're going to need is the probability of A and B. And using what we know from above, that's the probability of A times the probability of B, which is 3/6 times 3/6, which is 9/36. Okay, so we can use our formula. The probability of A or B is the probability of A plus the probability of B minus the probability of A or B. The probability of A is 3/6 plus the probability of B, which is 3/6, minus the probability of A and B, 9/36. 3/6 plus 3/6 is 1 whole, which is the same, right, as 36 over 36 minus 9 over 36, which is going to give us 27 over 36. And if we want to reduce that, we can, and it becomes 3/4. So the probability of A or B is 3/4. This works quite nicely. These do have to be independent events, and we'll talk a little bit about that more tomorrow. And for now, let's just take a look at a Venn diagram, how we can find the probability of an OR statement looking at a Venn diagram. It's a little bit easier than this. So if we can make a Venn diagram, I think that's a nice way to go. Okay, so let's take a look. Here we go. We can also determine the probability of an OR statement from a Venn diagram. So same setup as before, right? I've asked 30 students the same question, same Venn diagram. What's of the probability that a student travels more than 30 minutes to get to school or has a job, right? Remember our or when we're looking at our Venn diagrams, it's the whole space. And so the probability is 8 plus 7 plus 6 over our total 8 plus 7 plus 6 plus 9. And if we have 8 plus 7 plus 6, that's 21 over 30. So our probability, 21 over 30. We can reduce that if we want to 7 over 10. Okay, so this a little bit faster if we have a Venn diagram. So let's take a look at some practice questions. I just modified them a little bit. They'll make a little bit more sense this way. So the last part, let's just take a look here. So here's question 8. Okay, just a couple of changes that you're going to want to take a note of. rolling a six-sided die twice. Okay. B, we have a first roll and a second roll. C, we also have a first roll and a second roll. And D, we have a first roll and a second roll. All right, so this changes our question just a little bit. Question 9, we're choosing 2 balls at random. Okay, and let's see, question C, I think has changed a little bit. Question D maybe changed a little bit. I can't quite remember if I changed either of those, but kind of some things to note. And I think that's it. So hopefully this makes a little bit of sense to you, and we will reconvene tomorrow.